This example shows how can we actually formulate a demand function based on the stochastic willingness to pay for the bundling problem. So here we can see we say the willingness to pay of the products actually is between 0 to 500 is uniformly distributed. So now we have a uniform distribution for these two products respectively. Question is, what is the pair of prices would maximize Dell's monthly revenue from these two products? And another question is, would Dell gain if they would sell these two products only as a bundle? What would be the optimal price of the bundle? First, if sell the two products separately, so we can actually formulate the problem separately. For example, for the scanner, so the optimal revenue objective function is TPS times DPS, and for the printer is PP times PP times BP. So that's a revenue. So the question is we can actually maximize the revenue for the two products separately. In this problem, we can use any of them as an example. For example, because the willingness to pay for scanner is in the range 0 to 500 uniform distribution, then we can actually write the purchase probability or the demand function is the 10,000 times 500 minus p divided by 500. So this rearrange, then it's 20 times 500 minus p. Then we know that MP is P times dP. So you can use this to solve this problem in solver. So we have done that many times. So you will get a PS is $250 per unit. And here we can use in another way. We can do a derivative about this revenue function, because the revenue function is concave. So first order condition will give us optimal solution. So in this case, you can do DMP, first order derivative, equals to dP plus P times so this equals to 20 500 minus P plus P times 20. Oh, sorry, minus 20. Then rearrange this. This should be 0. Rearrange that, so you get PS equals $250 as well. So that's just two different ways to. So for example, here in solver, it's one way. You can also do that mathematical way. So the optimal solution actually is also 250. So that's how you got the optimal solution for separate selling in this slide. So in this problem, if we know the willingness to pay for each individual product, then we can use this two-dimensional area to show the purchase probability. So the general assumption is the total willingness to pay of the consumers on these two products greater than a bundle price, then the area, the shadowed area, should be the purchased area. Then we can use this to derive the demand function. So we try to work out the demand function when the bundle price is greater than 500 or less than 500. So when the P bundled price is less than 500, we can see the first graph here. So we need to calculate the ratio between the shadowed area and the squared area. So the shadowed area is, if I write it here, shadowed area actually is the squared area minus the small triangular on the left hand side, so which is p squared divided by 2. So the total square area is 500 square. So this actually is a purchase probability. So this purchase probability times the market size, which is 10,000. Then we got the demand function. So if we can mark this part as a purchase probability, then 10,000 is market size. So you got your demand function. Similarly, we can calculate the demand function for the P greater than 500 now with green color. So now we can see the bottom figure here. So the total triangular area, actually you can figure out by draw this figure a little bit further. So now you can see when the bundled price is greater than P, then we know this cross point is P. So that's why we know this small area is P minus 500. And then this area will be 500 minus P minus 500. And then we know how to calculate. So we can actually calculate first the shadowed area, which is, so this actually equals to 1000 minus P. So we can calculate half times 1000 minus P square. So that's a shadowed area. So your total squared area is 500 square times 10,000 market size. So that's another part of the demand when the P is greater than 500. So if you rearrange these two demand functions, then you get the function here we show. So now quickly just rearrange this a little bit. So now you can see the second one is easy to be rearranged. So 2 times 500 square, and the denominator is this, and then times 10,000. So this, which is the second part of the demand function, and when the P is less than 500, we can also rearrange it a bit. So now you can see here we use blue color. So here now you can see we have 1 minus 2 times 5 square spare P square. This is the first part times 10,000. So this same with the first part of this demand function. So that's how you get this demand function. So actually, in revenue management, the most important part is to estimate the demand. So this is just one example to show when you have two products or when the two sales are correlated. So how should we estimate the demand function?